Hey guys, in this video I'm going to discuss example 5.23 and example 5.24. In the previous video I discussed what is cumulative distribution function and how it works. Along with that I discussed example 5.22 where we had to find the CDFs for the max function and the min function, right? So in this video I'm going to discuss example 5.23 and 5.24, and both of these examples are just building on the concepts of CDF, right? So let's just start. So example 5.23 says that the diameter, say x, of an electric cable is assumed to be a continuous random variable fx is equal to 6x 1 minus x, such that my x lies between 0 and 1, right? First of all we need to check if fx is a PDF. Check if f of x is a PDF. So let's just find it. So 0 to 1, 6x 1 minus x, and if this is equal to 1, then we can say that this is a valid PDF. Right? So this means that we can take out 6 because it's a constant. So we'll be left with x minus x square, right? Dx. We have dx here. Right, so this will give me x square by 2 minus x cube by 3 from from 0 to 1. So this means that I'll be having 1 by 2 minus 1 by 3, right? This means that I'll be getting which is equal to 1, right? So this is a valid PDF. Yeah, so this is a valid PDF. This is 1 by 6. This is 3 minus 2 divided by 6, right? So this is a valid PDF. The second part says that obtain an expression for the CDF. Obtain an expression for the CDF. So the formula for my CDF is fx small x, where small x is my point and x is my random variable, from 0 or my lower limit. Let me just write it as negative infinity. So if my lower limit is negative infinity till x, and this is my PDF, if fx is my PDF, dx. This is the formula for my CDF, right? But in our case our lower limit is 0, right? So we'll be taking the lower limit as 0 and the upper limit will be x, and our PDF is 6x into 1 minus x, right? Dx. So this is 6, and the integral of this is x square by 2 minus x cube by 3, and my limits are 0 to x. Or I can just take this as 6t into 1 minus t, so that we don't get confused. So let me just take this as 6t into 1 minus t, and this will become dt. So this, my PDF is now 6t into 1 minus t dt, and let me just erase this. So my my result after integration becomes t square by 2 minus t cube by 3. And let me just change this formula a bit. Wait, let me just write this as ft dt, right? ft dt. So this will give me 6 x square by 2 minus x cube by 3, right? So this is my CDF. Let me check if we are right here. So what I can do is that I can multiply this by 6, so I can just reduce this expression or simplify this further. This will give me 3x square minus 2x cube, right? So this was our this becomes our CDF. Or let me just write this in a different form. My CDF finally becomes 3x square minus 2x cube when my x lies between 0 and 1, and for my first of all it becomes 3x square minus 2x cube for my x lying between 0 and 1. It becomes 0 for x less than 0 because we don't have any PDF here, and it becomes 1 for any x greater than 1 because I already have this expression. And if I integrate this from 0 to 1, this will give me basically the CDF of 1, which is equal to 1 here, and adding this with 0 because there is no PDF present for x greater than 1, so this will give me 1, right? I have discussed all of this in the previous class, you can check that out. I tried to explain all of this in the previous class, so please check it so that you get a good understanding of this topic. So my third part now says that compute p x less than equal to half conditional 1 by 3 conditional my x lying between 1 by 3 and 2 by 3, right? So the formula for conditional probability is, let me just write, if my events are A conditional B, so the formula for this is PA intersection B divided by P of B. So for finding P probability of x less than equal to half conditional that x lies between 1 by 3 and 2 by 3, this will be equal to P x less than equal to half intersection x lying between 1 by 3 and 2 by 3 divided by probability of x lying between 1 by 3 and 2 by 3, right? So if my x is less than equal to half and also lies between 1 by 3 and 2 by 3, so the value of 1 by 3 is 0.33 and the value of 2 by 3 is 0.66, right? Something like this. So I need to find my x being less than equal to half, but also lies between 1 by 3 and 2 by 3. This implies that my x should essentially lie between 1 by 3 and 1 by 2, right? So this will satisfy both of these statements, this also and this also. So my numerator is this value, my numerator, this is my numerator, this gets reduced to this. So if I want to find this value, I'll just integrate this from integrate my PDF from 1 by 3 to half. My lower limit will be 1 by 3 and my upper limit will be half, and my PDF was 6x into 1 minus x dx, which is equal to 6x, or let me go to the, yes, so we were finding this value, right? So you're finding this value, so this is integral 1 by 3 to 1 by 2 1 minus x dx. This is so this gives me which gives me Now 3 by 4 minus 2 by 8, so 1 by 4. So 3 by 4 minus 1 by 4 will give me 2 by 4 minus, so this is 3 by 9 and this is 2 by 27, so this is 3 into 3, right? So this is 9 minus 2, 7 by 27, 7 by 27. So this is half minus 7 by 27. Taking the LCM will give me 54. So this is 27 minus 7, this is 20. So 20 upon 54. So 2 tens are, right? So this is 2 tens are 10 upon 27. Wait, this is 2, this is 27, and this will be 14. Wait. So if this is 54, if my LCM is 54, so this will be 2 and 27, 27 minus 7 into 2, 14, minus 14, so this will be 13 upon 54, right? So this is the value of my numerator. The value of my numerator is, or the value of x lying between 1 by 3 and 1 by 2 is 13 upon 54. Now finding the value of the denominator. This is equal to 3x square minus 2x cube from 1 by 3 to 2 by 3. So this gives me 3 into the square of 2 by 3, so 4 by 9, minus 2 into the cube of 2 by 3, so this gives me 8 upon 27. Negative the square of 1 by 3, 1 by 9, minus the cube of 1 by 3, so 1 by 27. So this gives me 12 upon 9 and 16 upon 27. So 12 upon 9 minus 16 upon 27 minus 3 upon 9 minus 2 upon 27. So this will give me, so 12 minus 3, 9 upon 9, 1. 12 minus 3, 9 upon 9, 1, and minus 16 upon 27 plus 2 upon 27 gives me minus 14 upon 27. Minus 14 upon 27. So 27 minus 14 gives me again 13. So this is 13 upon 27, right? So this is 13 upon 27. 27 minus 10. 27 minus 10. 17 and 4. 13 upon 27. So my denominator becomes. Now if I include 1 by 3 or 2 by 3, it doesn't make any difference because we are talking about continuous distributions. So this gives me 13 upon 27 in the denominator. So finally my value of x less than equal to half, conditional that x lies between 1 by 3 and 2 by 3, becomes 13 upon 54 divided by 13 upon 27, 27 into 2, 1 by 2, which is 1 by 2, right? Which becomes 1 by 2. Let me just check if we are right. Give me just 1 second. Yeah, they have made some error in the book while there's a printing mistake, but what we have done is correct, right? So the answer is 1 by 2. So let's just solve the fourth part now. We need to determine the number k such that determine the number k such that px less than k is equal to px greater than k. Px less than k is equal to px greater than k. So So px less than k is equal to fx and k, right? So this is the CDF of k. Now whether I include k or not, it doesn't matter, right? Where k is my point and x is my random variable. X is the random variable and k is my point, right? And px greater than k is equal to 1 minus px less than k, and this is equal 1 minus px less than k is again the CDF of fx when the point is k. So my px less than k is equal to my px greater than k when fxk is equal to 1 minus fxk. So taking this to the other side, 2 fxk is equal to 1, which implies that fxk is equal to 1 by 2. Right. So p x less than k is equal to 1 by 2. This means that my lower limit was 0, right? My lower limit was 0, yeah. So 0 to k, 6x 1 minus x dx should be equal to half. So this gives me 3x square minus 2x cube from 0 to k should be equal to half, which implies 3k square minus 3k square minus 2k cube is equal to half. So just multiplying 2, so this gives me 6k square minus 4k cube is equal to 1, which means my 4k cube minus 6k square plus 1 is equal to 0. Now let just applying trial and error, let k be half. So this gives me 4 into 1 by 8 minus 6 into 1 by 4 plus 1 is equal to 0. So this gives me 1 by 2. This is 2 3s are 6, 2 2s are 4. So this becomes 1 by 2 minus 3 by 2 plus 1, 1 by 2 minus 3 by 2 plus 1, which is equal to 0. Therefore k is equal to half is a root. Now I can stop here also, but let me just check the other roots. We don't know if our other roots will be lying between 0 and 1 or not. I don't think so, but let's just check. So my first root was half, so my applying long division, so my root becomes k minus, my expression becomes k minus half, and my expression was 4k cube minus 6k square plus 1. Now just applying long division here, so 4k square, this gives me 4k cube plus minus this, and this gets cancelled. Multiplying this gives me minus 2k square plus, so this gives me minus 4k square plus 1. So just multiplying this by minus 4k now, minus 4k, this gives me minus 4k square, minus 4k square plus, and minus 4k with half gives me plus 2k and negative of this. So this gives me minus 2k plus 1, and multiplying this with plus with negative 2 with negative 2 with negative 2 gives me minus 2k plus 1. So positive of this, negative of this, again we get 0. So my other root is my other two roots will be given, I'll be getting my other two roots from this expression, right? So just this becomes k square minus k minus 2 is equal to 0. So k is minus b, so minus plus, plus minus root b square is 1 minus 4 into 1 minus 2. So 4 into 8, 4 into 2, 8. So this becomes 9 by 2 into 1, right? So my roots will be, my k will be 1 plus minus 3 by 2. So my roots will be k is equal to 1 plus 3, 4. So this will be 2, and 1 minus 3 minus 2 minus 1. And my earlier I found that my root was k is equal to half, right? So my roots are k is equal to half, comma 2, comma minus 1, and only this half. K is equal to half qualifies because only k is equal to half lies between 0 and 1. Therefore k is equal to half is our desired solution, and we'll be rejecting this. Reject, because they do not lie between the limits of x, so they cannot be the values for x. Reject these values. We have accepted this. Accept k is equal to half. Let me check. Wait, I made an error here. This will be plus minus root 3. So this will become so my roots are not k is equal to 2 comma minus 1. So wait, let me just so 1 plus root 3 is 2.273 divided by 2 gives me some value greater than 1, and 1, wait a minute, let me check if they have made an error or if I have made an error. So I substitute 2 here, so 4 into 2, if I substitute 2 here, so this gives me, wait, let me just 4 into 2 is 4 into, so 4 into 2 is 4 into 8 is 32, 6 into 4 is 24. Yeah, so I've made an error here. This should be equal to 4ac. So wait, if I take this becomes 2 square, and this becomes minus 1, right? So this is 3. This becomes if I take just 2 common from here, so minus b plus minus, this becomes plus 2 plus minus, so this becomes 4 into b square minus 4ac, right? 4 minus 4 into 2, 4 minus 4 into 2, 8 into 1. Let me just find the other roots. So my b square minus 4ac for this will become 4 minus 4 into 2 into c is minus 1. 4 minus 4 into 2, 8, and plus 1, so this becomes 8. 4 plus 8 is 12. So this gives me root 12. So my roots are, my other two roots are 2 into 2 is 4. So 3 into 4, so 4 can come out, so 2 will be coming out of the root. So if I just take 2 and divide it from the numerator and denominator, I'll be getting 1 plus minus root 3 by 2, right? And 1 plus root 3 is 2.73 something divided by 2 will give me any value of k greater than 1, and 1 minus root 3 will give me negative 0.73 divided by 2, which will give me a negative number. Again, that does not lie between 0 and 1, hence our only value that is acceptable is k is equal to half. I made an error in finding the other roots, that's why I went back and corrected myself. But yeah, the core idea was that the other two values were getting cancelled, right? And k is equal to half was our final value. So this is the end of the example 5.23. I'll be now discussing example 5.24. Let x be a continuous random variable with PDF given as x is a continuous random variable. My PDF of x is kx k minus kx plus 3k and 0 elsewhere. You know, a lot of times the calculations are very basic and I can solve them mentally, but so that I don't make any error, any small error here or there, I just try to write all of these things and check, right? So what I need to do in this question is, this is my PDF, right? In this question we need to find the value of k. Find k. Let's just find k. For finding k, kx 0 to 1 plus, I am just finding the value of the PDF over the limits of x, and this should be equal to 1, right? So from 0 to 1 we have kx as the PDF. From 1 to 2 for the values of x lying between 1 and 2 we have the PDF as k, and for 2 to 3 we have the PDF as minus kx plus 3k, and all of this should be equal to 1 because this represents the area under the curve. So from 0 to 1 we have kx, right? So this becomes kx square by 2 0 to 1 plus k for 1 to 2, so this becomes kx after integrating 1 to 2, and we have minus kx plus 3k for 2 to 3, so minus kx plus 3k becomes minus kx square by 2 from 2 to 3 plus 3k square by 2 from 2 to 3. This should be equal to 1. So this gives me k 1 by 2 plus k 2 minus 1 plus negative k 9 minus 4 upon 2 plus 3 by 2, and wait, this is kx square. This is kx square. K is just a constant, so this wait, let me just write this again. So this value is plus 3k, right? So this becomes plus 3k, so this gives me plus 3k. Oh, this is plus 3k, right? So this becomes plus 3kx. So this just gives me not 3 by 2. This gives me 3k 3 minus 2. This should be equal to 1. K by 2 plus k, and this becomes 5 by 2 minus 5 by 2k plus 3k, and this should be equal to 1. So this becomes 4k and k by 2 minus 5 by 2, so this becomes minus 4 by 2k, which is minus 2k, and we have 4k here. 4k is equal to 1, which implies minus 2k and 4k, so this becomes 2k is equal to 1, implies k is equal to half. So k should be half. Let me just check if k is equal to half. Yeah, k is equal to half in this question also. So our PDF, we can write the PDF now, where we can just write half in place of k. So what I'll be getting is, my PDF was kx for x lying between 0 and 1, so this becomes half of x for x lying between 0 and 1, and k, so k for x lying between 1 and 2. It doesn't matter if I include the end values or not, but I am just writing the PDF in the manner that they have written in. Minus kx plus 3k, so minus half x plus 3 by 2, where my x lies between 2 and 3, and it is 0 elsewhere. Now we need to determine the CDF. Finding the CDF, the formula for CDF is less than equal to px less than equal to small x, where small x is my point and capital X is my random variable, right? So this gives me negative infinity or the lower limit. I'm just writing negative infinity here, till x fx dx. Now we know the value of our PDF, right? So for I am finding the CDF now. Finding the CDF for, this is case 1, for x lies between for x less than 0. For x less than 0 we don't have any PDF. For x less than 0 we don't have any PDF. So my f x 0 for x less than 0, not 0 here. So fx is 0 here because no PDF is present here, and my PDF is not defined for x less than 0. For x belongs to 0, 1. Now doesn't matter if I include 1 or not, they have not included, therefore I am representing in the manner that they have represented in, right? From 0 to 1. So from 0 to 1, right? So this is 0 to x, and my PDF here was was half of x, half of x dx, right? Yeah. So this gives me half of x square by 2, 0 to x, 1 by 4 x square. Let me just write this as t so that you don't get confused. So this becomes t square. So just substituting x here gives me 1 by 4 x square. This is my CDF for x less than 0 and 1. Now for x belongs to 1, 2. Now for x lying between 1 and 2, this means that any x lying between 1 and 2. When any x lies between 1 and 2, see, if I find the CDF in this case, I'll be putting in the lower limit as 1 and the upper limit as x, and I'll be just integrating this function, right? And this will be my CDF. Am I right? No, I'm wrong. Why? Because 1 to 2 gives me the probability of any x which is greater than 1 but less than 2 or equal to 2 here, but just assume that x is less than 2 for a minute. So for example, x is less than 2, and the value of this integral gives me the value of the area under the curve from 1, for example 1 is here, to 2, and my x lies between here, my x lies here, right? So this integral gives me the area, this shaded area. This integral gives me this shaded area, but my CDF says that I need this whole area before x. I need this whole area before x, right? This whole area, including this shaded area and this whole dotted area. I need this whole area. I need this whole area, right? I need this whole area for finding the CDF, right? So what I'll be doing is that I'll be writing this again and I'll be including the area from or the CDF of 1. So this will become fx where my point is 1, x random variable where my point is 1. So my CDF will become, for example, this is my 1, this is my x. For any x lying between 1 and 2, x can lie anywhere, right? So this will be this area and the CDF of 1 and the CDF of 1 and this area, right? So this area is given by this integral, and see, so 1 to x, and my PDF for x lying between 1 and 2 was, I'm just seeing the previous slide here. When I move my eyes from the center of the screen to the left side of the screen, I'm just seeing the previous slide, right? So from 1 to x I have half, right? So half is my PDF, right? So this expression, the second expression gives me this area from 1 to x, and this expression, which is the CDF of 1, gives me this whole area. So earlier we found the CDF for any x in the previous part. In the first part we found the CDF for any x lying between 0 and 1. So we'll just substitute 1 in the previous expression and we'll get the CDF of 1. So finally what my value reduces to is, for x belongs to 1, 2, we get the second part, we get fx as f of 1, we get the fx as fx1 plus 1 to x half dx, and f of 1 was, now I need to just go the previous part, right? So this was 1 by 4 x square for x lying between 0 and 1. This was the third part. Wait, let me just write this. This was the third part. This was the third part. Yeah, and I'm just writing this third part again in a neat manner, right? So this is my third part only, continuing with my third part. So this was 1 by 4 x square, and my x here is 1, so 1 by 4. This becomes 1 by 4 square. 1 by 4 into 1 square, and this becomes x by 2. Again, let me just represent this as dt, and this becomes t dt. I'm writing dt just so that you don't get confused while putting the limits. So this whole expression becomes 1 by 4, and just substituting the limits gives me x minus 1 by 2. So my whole fx when my x lies between 1 and 2 is 1 by multiplying this expression by 2 gives me 2x minus 2 minus 2 plus 1 minus 1, 2x minus 1 by 4. Now for x belongs to 2 to 3, for x belonging to my CDF now becomes my 3 is, for example, here, 3 is here, 2 is here, 1 is here, right? So my CDF for any x lying between 1 and 2 was 2x minus 1 by 2. So my so I can write this expression as f of 2. F of 2x will give me this whole area till 2, right? And I found the expression for this x lying between 1 and 2 in the previous part. So I'll be getting this and adding this with this integral. This is equal to 2 to 3, and my PDF when my x was lying between 2 and 3 was minus half x plus 3 by 2, minus half x plus 3 by 2, minus half x plus 3 by 2, minus half x plus 3 by 2 dt. dt, and this is x, not 3. Wait, let me just write this as x. This integral is for any x lying between, for example, this is x. For any x lying between, let me just write this. So for example, if my 3 is here, somewhere here, my 3 is here, my 2 is here, my x lies between here. So for finding the CDF of x, I'll be adding this expression, that is f of 2 with the integral this from 2 to x, right? This integral. So this gives me f of x as, so this is 2x minus 1, so 2 into 2 minus 1 by 2 plus this becomes minus half t square by 2 plus 3 by 2 t from 2 to x. So this becomes 2 into 2, 4, 4 minus 3, 4 minus 1, 3, 3 by 2 plus, now substituting the values, minus t square by 4 minus x square by 4 minus x square by 4 plus 3 by 2x minus plus, so this gives me 4 upon 4, this gives me plus 1, and subtracting this, minus 3 by 2 into 2, so this gives me minus 3. By 2 minus x square by 4 plus 3 by 2x minus 2. So this gives me 3 by 2x minus x square by 4, 3 by 2x minus x square by 4, and 3 by 2 minus 2 gives me minus half. Yeah, minus half. So finally I'll be getting, just multiplying this, 6x minus x square minus 2 by 4. So my fx2 becomes my fx for x lying between this is not fx2, this is just fx, sorry, this is for any x lying between 2 and 3, right? This is fx2, this expression, wait, this expression is fx2, this 3 by 2 is fx2, right? So finally my fx for any x lying between 2 and 3 becomes 6x minus x square minus 2 divided by 4. Now the fifth part actually, the fifth part, for any x greater than 3, for any x greater than 3, our probability will be f of 3, and we don't have any PDF here, so we can just write 0. So if I substitute 3 in the above expression, I'll be getting 6 into 3 minus the square of 3 is 9 minus 2 divided by 4. So fx becomes 18 minus 9 minus 2 divided by 4. Or do I have a PDF here? Let me just check if I have a PDF here. No, I don't have a PDF here. I have made a mistake in my calculation. Wait, let me just check. Minus 2, 3 by 2 minus 2, so 2 into 4 minus 4. Have I made some kind of mistake? Yeah, wait, let me just check. 3 by 2 minus 4 divided by 4 minus 1 minus plus 1, 3 by 2 into 2 becomes 3 minus 3, yeah, and this is minus x square by 4, and this is 3 by 2. Let me just check. 2 into 4, 4 minus 1, 3 by 2, 3 by 2 minus this is a negative sign, right? minus x square by 4 plus 3 by 2x minus 1 plus 1 plus 3 by 2x, yeah, plus 1 minus 3 plus 1 minus 3 should give me 3 by 2 minus 2 minus 1 by 2. So my expression should be correct. Let me just check from the book. I've made an error here. I need to check where I made an error. From 2 to x. Let me just check where I made an error. For x lying between 1 and 2. For x lying between 1 and 2. So f of 2 becomes 2 into 2, 4. 4 minus 1, 3. 3 by 4. This is 3 by 4. Wait, yeah. So I made an error here. This was 2x minus 1 by 4. So this should be 3 by 4, right? So this is 3 by 4. So 3 by 2x minus x square by 4. 3 by 4 minus 2 becomes minus 5 by 4. Minus 5 by 4. I'm so sorry. This becomes minus 5 by 4. So ultimately what I have is this is 5 only. So I have 6x minus x square minus 5. 6x square minus x 6x minus x square minus 5. I have minus 5 here. So this is minus 5. Right. So the error here was that I was taking my f of 2 as 2 into 2 minus 1 by 2, but my expression for any for my CDF for x lying between 1 and 2 was 2x minus 1 by 4. So yeah, this caused the whole error, right? So I'm just removing this. I was just telling you guys so that you don't get confused. So 18 minus 9 is 9. 9 minus 5 is 4. So 4 by 4 will become 1. So for any x, I'm so sorry for the error. For any x greater than 3, my CDF will be 1. Now let's just write the expression for the CDF. So this was 0 for x less than 0, and this was let me just move above. So this was 1 by 4 x square, when my 1 by 4 x square for x belonging to 0 and 1, and it was for 1 to 2, yeah. So for 1 to 2 it was 2x minus 1 by 4. 2x minus 1 by 4, I took it as 2x minus 1 by 2. That made cause the whole error. For x lying between 1 and 2, again if I include 1 or 2 in the domain while writing in the intervals, it does not matter because it's a continuous random variable. Now for x lying between 2 and 3, my expression becomes 6x minus x square minus 5 by 4. Just putting a comma here. For x lying between 2 and 3, and it becomes 1 for any x greater than equal to 3. So let me just check from the book. 0 x square by 4, 2x minus 1 by 4, yeah, 6x square 6x minus x square minus 5 by 4, yes, and 1. So this was our CDF.